3 years ago, after a bad breakup, Brian went on a month-long eating binge. He's been carrying around about 20 extra pounds ever since. One day, while watching a particularly inspiring episode of Biggest Loser, he decides to lose 20 pounds by running on the treadmill. It takes about 31,500 joules of energy to lose 1 kilogram of body mass. The amount of energy that it takes for a person to run a mile is proportionate to their mass. Brian amasses 63.57 kilograms, and at his mass will burn approximately a fifth of a joule every meter he runs. At his goal mass, 54.49 kilograms, he will only burn 0.18 joules every meter. According to physics, the amount of energy he burns total is equal to the integral of the force it takes for him to run times the differential of distance. Energy is expressed as force times distance. Therefore, the force it takes for him to run can be expressed as the ratio of energy to distance. Because the ratio of energy to distance is proportionate to his mass, it can be expressed as the ratio of energy to distance and mass times mass. Brian's mass can be expressed as his current mass, 63.57 kilograms, minus the energy he uses to run divided by 31,000. I was stuck. The equations looped into each other. If I substituted mass in the energy equation, I got an integral of an integral, neither of which I could solve. I was trapped. I had told Miss Burlack that this would be my project, and no matter how unsolvable it was Saturday and the project was due the following Monday. I proceeded to attempt different methods for the next few hours. I'm done for. The only way for me to get an A in the class is to ace the project. I just have to keep my senior year 4.0. Oh God.
Scott, are you alright? Are we still gonna film that AP Calc video tomorrow?
Pounds.
Scott, the tornado drill was last week. What are you doing?
Pounds.
It took a while, but eventually I figured it out. By differentiating the energy equation with respect to distance, it is found that the change in energy with respect to distance is equal to the ratio of energy to distance and mass times mass. Because a person of 140 pounds burns about a fifth of a joule every meter, substituting those values in the equation will give the ratio's numerical value. The ratio is constant for all mass, as substituting the other values proves. Differentiating the mass equation with respect to distance gives the change in mass with respect to distance is equal to the negative ratio of energy to distance and mass divided by 31,500 times mass. Solving for mass allows the equation to be substituted back into the derivative of the energy equation. The differential of distance on both sides cancels, leaving the differential of energy equal to negative 31,500 times the differential of mass. By multiplying the derivative of the energy equation by the differential of distance, it can be set equal to the previous equation. The equation can finally be integrated by moving the mass and the derivative of the energy equation over. The distance ran is equal to negative 31,500 divided by the ratio of energy to distance and mass times the natural logarithm of mass plus the constant c. To find c, substitute Brian's starting mass in a distance of 0. The distance Brian runs is equal to 31,500 divided by the ratio of energy to distance and mass times the natural logarithm of Brian's starting mass divided by his current mass. According to this formula, Brian would have to run approximately 1.5 million meters to lose 20 pounds, or 917 miles. After a year of running 2.5 miles a day, Brian lost the weight. Everything was going great, and he had even found a much nicer girlfriend until she broke up with him too.